delta G is equal to negative Nfe in Fe. This shows that max cell potential is directly related to the free energy difference between the reactants and products in the cell. A positive E cell will correspond to a negative delta G. N is going to equal the number of electrons that are transferred in the reaction. F is a constant, Faraday's constant, and it's the charge on 1 mole of electrons. That's 96,485 coulombs per mole. And E is our E cell, which remember was in joules per coulomb. Very important to realize that it's in volts, which is joules per coulomb. Delta G is normally in kilojoules, so you have to make sure that they're in the same unit. It's much easier to convert your kilojoules to joules and then use your E cell as it is without having to convert that unit. Here's our new equation. Delta G is equal to negative Nfe. In thermodynamics, we said delta G is equal to negative Ratlink. So combining those two, we have Nfe equals Ratlink, which relates our E cell to our K value. So if we know E cell, we can calculate our equilibrium constant. So let's use the standard reduction potentials here to calculate delta G for the reaction. Step 1 is calculate your E cell using the standard reduction potentials. Restart when you have your E cell for the reaction. So according to the equation, we need to keep the copper value as it is, and then we're going to reverse this one. And again, we reverse the bottom one because it says Fe to Fe plus 2. We've got to reverse the one they had reversed in the equation. That gives us 0.78 volts. And if we look at our equations, we have 2 electrons and 2 electrons. So that means 2 electrons are transferred. So delta G equals negative Nfe. We don't know delta G, but we know that our N is 2 because 2 electrons were transferred. F is a constant, 96,485, and our E was 0.78 volts. Plugging this in, we get negative 150,516 joules, which we can convert to kilojoules. So the question asks, is this a spontaneous reaction? Well, delta G is negative, so yes, it's thermodynamically favorable because delta G is negative. We could have answered the is this reaction spontaneous just by looking at our E cell. Since our E cell was positive, we knew that we had to have a negative delta G. Here's another example. It says, will 1 molar nitric acid dissolve gold to form a 1 molar gold-3 solution? The only difference on this one is if you look at our reactions, we have our electrons on opposite sides. The reaction that is reversed has already been reversed because we want to make sure that we have gold metal on the reactant side and nitric acid on the reactant side, since those two have to react. So go ahead and calculate your E cell for this reaction. You should get negative 0.54 volts. Since E cell is negative, delta G is positive. So since E cell is negative, delta G will be positive, so no, this will not occur on its own. Go ahead and pause the video and determine your delta G for this reaction. Restart when you're done. For this one, we had tin as a solid as a reactant, so this one should have been reversed. So E is equal to 0.15 plus 0.14 or 0.29 volts. Delta G is equal to negative. Our electrons, we have 2 and 2, so we have 2 electrons transferred. So we get negative 56 kilojoules, or B. On this one, you're given delta G and how many electrons are transferred, and you're trying to calculate Ecell. So pause the video and calculate your Ecell. You should have calculated your delta G to joules. We had 4 electrons. So solving that out, X is my Ecell. 1.995 volts, so B is the closest answer. On this one, we are calculating the number of electrons that were transferred. So go ahead and pause the video and calculate the number of electrons. Round into the nearest whole number. They gave you the equilibrium constant, and they gave you the Ecell. So remember that we said a few minutes ago that N equals, or NFE equals RT ln K. Since delta G equals negative Neffy and delta G equaled negative Ratlink, we could set them equal to each other. We're looking for N. F is a constant. Our E was 0.04 volts. R, remember from our previous unit, was 8.314. That's in joules already. Temperature is 298. And then ln of 22.4. I'm going to solve everything on the right first since I don't have any x's. And so I get 2. We said that for it to be a standard cell, everything is going to be in 1 molarity. But if it's not in 1 molarity, how does that affect cell potential? If the concentrations are not at standard concentration, then you can figure out what will happen to cell potential qualitatively by determining if Q will be greater than or less than 1. Q starts at 1 because all of our concentrations are 1. So 1 over 1 equals 1. As the cell operates, Q is going to get bigger and bigger as the voltage approaches 0, as equilibrium is established. So if Q is greater than 1, it's closer to K, and closer to equilibrium, and closer to 0 voltage. So the voltage is going to be less than standard. If Q is greater than 1, then the voltage will be greater as it tries to achieve equilibrium. So let's see that in context of a problem. Here we have our reaction, and it says if we increase cerium plus 4. So this one's 1 molarity, this one's 1 molarity. And if we increase this one to, let's say, 3 molarity, we would have 1 over 3 squared versus 1 over 1 being 1. So now we have a number that is less than 1. So since Q is going to be less than 1, this would increase the driving force on the electrons, so cell potential will increase. Cell potential, again, being our E. So the E will be larger than if it was 1 molar all the way across. Let's look at 2 more examples. So on A, it says that we have 2 molar for this one. So this one is still 1 molar because it tells us 1 molar. So we have 1 molar and 2 molar. This time our product increased. So if I do 2 squared over 1, that gives me 4. That's larger than 1. So my Q is greater than 1, so Ecell should decrease. And then for B, we have 1 molar for our product and 3 molar for our reactant. Since we have more reactant than product, our Q is going to be less than 1. So Ecell will be greater than Ecell at standard. So our Ecell will be bigger than if it was at standard conditions.